Welcome to this video. Together we'll be solving an entire past maths exam of the IGCSE curriculum. And therefore, before we start, it's important to give credits to Cambridge because this is their exam. And these are their questions. We are just here together to help each other to understand maths a little bit better. So we'll be solving the May-June 2015 paper 21, which is the shorter paper, the first paper, if you like, of the extended curriculum. Please go to my website explainingmaths.com, where you'll find all my resources for free, including past paper questions, but I explain all the topics for you for free. So we'll be moving on now shortly to the first questions, but before we do, always it's important to have a look at the beginning at those instructions, because they say some important things that, for instance, when it comes to accuracy. Okay, so you have when the accuracy is not specified, it says then and the answer is not exact, you have to give it to 3 significant figures. And if your answer is in degrees, so we're talking about angles, then 1 decimal place. So please take care of rounding. Okay, now let's start with the first question. So this is the first page of the exam, and as you can see, always shorter questions. And many times, like now, they start with a question about directed numbers. And what does it say? It says at noon the temperature was 4 degrees Celsius and midnight the temperature was minus 5.5 degrees Celsius. Work out the difference in temperature between noon and midnight. So many times these questions are about difference in height, or indeed difference in temperature. So what do you need to realize is that if you have a thermometer, you have 0 degrees Celsius there, then at noon it was, what do they say, 4 degrees Celsius. In the night it is minus 5.5 degrees Celsius. So the difference means what is the length of this on a number line. And how can you calculate that? You could do 5.5 if you take it as a positive plus 4, because that's going to be 5.5 steps plus another 4, so 9.5 steps, so 9.5 or 9.5, that would be the difference. Good, moving on to the second question, which is a calculator question. They're testing if you're able to use a calculator. And don't think too easily about these questions because many students make mistakes with it. Okay, so take care and plug in the numbers properly. Perhaps do it a couple of times. And I personally always work out first what is inside the square root sign in this case. I work that out. And then you do square root of your answer in your calculator, and then you're going to write down your answer. And if you do that properly, you should get 7.37, corrected to 3 significant figures, because all non-exact answers, 3 significant figures. Moving on to question 3, write in standard form. As you can see, all 1-point questions. Standard form, which is a way of writing very large numbers or very small numbers in a more sensible manner. And you always start with, let's say, the first number I say, which is not 0, 2, followed by decimal, and then the remaining numbers, but not just the 7, not the zeros after the 7 anymore. So you start with 2.7, and then you have to do it times 10 to the power. To the power what? And you have to count the amount of steps you've moved the decimal point. So if I can make this a little bit bigger, am I able to do that? I think I am. Yeah, look at that. Technology, ladies and gentlemen. Alright, so how many steps? The decimal point now is here, just after that 0. And if I'm putting it between the 2 and the 7, then I'm moving it 1, 2, 3, 4, 5 steps. So it's going to be times 10 to the power 5. There you go. Now I want to decrease the size a little bit. There we go. Expand and simplify algebra. So for 2 points, so you want to show some workings there. And your first point will be the expanding part, and then simplifying, which means combining the like terms. So I'm going to make it a little bit bigger again. I did enjoy that. So let's expand it first. What does that mean? That means basically get rid of those brackets. So multiply each term inside the brackets by x, and there each term by 5. So what does that look like? It's going to be 2x squared plus 3x, and then the second set of brackets, 5 times x, so that's 5x, and 5 times minus 7, minus 35. Then combining the like terms, I only have one term in x squared, so I can say 2x squared. But I have, let me see, I have two terms, 3x and 5x. There's two terms in x, so that will be 8x. And then my constant minus 35. Good. Moving on, no time to waste. I want to decrease again. There we go. It's something about probability. If I see that correctly, Paul and Sammy take part in a race. The probability that Paul wins the race is 9/35. And the probability that Sam wins the race is 26%. And as you know, you can write fractions, decimals, and percentages, and they all mean the same thing, a part of the whole. Okay, who is more likely to win the race, and give reason for your answer. Now, what you need to do is, in able to compare those probabilities, either write both of them as a fraction, or both of them as a percentage, or both of them as a decimal. Okay, so it's really up to you. What shall I do? I'm not sure actually what I'm going to do. I'm gonna write them as a percentage. Why not? So Paul 9/35. So Sammy is already written as a percentage. Paul 9/35. So I gotta somehow turn that into 9/100. So in my calculator I can do 9 divided by 35, and I'm going to times that by 100, and then my calculator is going to give me 25.7. Yeah, so as a percentage, the 9/35 is 25.7%. So now I can compare the probabilities easier, and then I can see that the probability that Sammy wins is slightly higher than if Paul wins. So my answer is going to be Sammy. Let me write it there. And because I'm not going to write it down, but what should I be writing down now is because the chance that he wins is 26%, which is greater than 25.7% of Paul to win the race. So again, to answer question 5, either turn both of them into a percentage like I did, or turn the 26% into a fraction and then compare it. Make sure the denominators are the same then, or both as a decimal. Okay, moving on to the next page, explainingmaths.com. So here we are again, a couple of questions, second page, and let's start straight away. It says rice is sold in 75 gram packs and 120 gram packs, and the masses of both packs are given correct to the nearest gram. Okay, so they have been rounded, they're not exact. Calculate the lower bound for the difference in mass between the two packs. So what is the smallest possible difference between the mass of the two packs? Now, then you need to realize that you do not just take the lower bound of each pack, because the smallest possible difference, then the lower pack, if I look at the lower pack and I put the lower pack, the less heavy pack and the heavier pack here, then to make sure that this difference is as small as possible, then I want the 75 to be as high as possible and the 120 to be as small as possible. So what do I mean with that? I have to take the upper bound for the 75 and the lower bound for the 120 to get the lower bound for the difference. Okay, so do not just automatically calculate the lower bound of 75, lower bound of 120. No, the upper bound from the 75 and the lower bound of the 120 are going to give me the lower bound for the difference. Okay, so it's to the nearest gram. That makes the upper bound for the 75, 75.5, and the lower bound for the 120 then will be 119.5. And you need to write down those numbers. They give you points, so please do not skip them. It's for 2 points, so you want to write down some workings. So what is the lower bound for the difference? So I'll have to do 119.5, take away the 75.5, because I'm interested now in the difference. And that's going to give me an answer of 44. There we go. Moving on to the next question, simplify. Some algebra up there. And you know, whenever I teach this to my kids for the first time, I tell them, yeah, this means 6 times u divided by w times 4 times u times w times w times w times w to m. So they're all time signs in between, although we don't see them. Now, because it's to the power -3, that w, I'm just going to rewrite that. So just to make my life a little bit easier, I'm going to say 6u over w to the power 3, yeah? Because that is what that means. Yeah? The u has a power 1, so a positive index, so does the 6. It's only the w which is to the power -3, so over w to the power 3, times 4u w to the power 6. I'm just going to say over 1 if that makes sense, because multiplying fractions, you multiply the numerators with each other, and then you multiply the denominators with each other, so that 1 there kind of reminds me of that. Now, of course, we then have to simplify afterwards, yeah? But I always prefer... Oh, what do I do? Sorry. Ignore that scratch, yeah? I just wanted to show you, I always prefer to multiply first and then simplify. So I'll do 6 times 4, which is 24, and I do u times u, which is u squared, and then I have a w to the power 6 over, and w to the power 3 times 1 is w to the power 3. But then I have to simplify, get rid of the common factor, and the common factor are those w's. I have w in the denominator, so I can take away 3 w's in the numerator. So my final answer will be, I can just write that here then, 24 u squared w to the power 3. Yeah? So ignore that little scratch there. So there you go. Continuing for 3 points now, the point A has coordinates -4, 6, and point B 7, -2. Calculate the length of AB. Now, what I always think is very useful in these cases, just a quick sketch for 3 points, so it's probably some work. So we are talking about coordinates, and then point A -4, 6, so nothing fancy. Don't invest too much time, but just a quick sketch. -4, 6, so a negative x and a positive y coordinate. And point B, 7, -2, so all the way in the other direction. Let's say it's over there, B, 7, -2, so 7 in the horizontal direction and then a -2 in the y direction. And what is the length? So they're asking me now, how long is this line segment? Okay, now making that sketch will remind you of Mr. Pythagoras and his brilliant theorem, because we have to turn that into a right-angled triangle. And then we can say, so basically they're asking me for the hypotenuse. I'm just going to put an x there. And what is the length of my A and my B, or my B here and A there, doesn't really matter. What is the length of this? So this is the horizontal difference, if you like, from -4 here all the way to 7, so that length is 11. There you go. And vertically from 6 to -2, so that length will be 8. And then it's a fairly straightforward question. That's what I believe anyway. Always, to honor Mr. Pythagoras, let's write down a squared plus b squared equals c squared. And we're going to start with that. We're looking for the hypotenuse, so x squared, and then 8 squared plus 11 squared equals x squared. Or, oh, don't forget the square, John. There we go. Or 11 squared plus 8 squared, doesn't matter. 64 plus 121 equals x squared. I didn't use a calculator up till now, by the way. I'm not sure what about you, but I don't think you really need calculators. Maybe now you'd like to have a calculator. So x is the square root, what is that, 185, I believe. Now you want a calculator. 3 significant figures, ladies and gentlemen, 13.6 units for 3 points. Thank you very much. All right. Moving on, question 9 already. This goes really well. Without using a calculator, work out 1/4/5 divided by 3/7. Show all your working and give your answer as a fraction in its lowest terms. Okay, now I have to show all my workings, but maybe your calculator can still inspire you of what the answer should be, if you have forgotten how to do this. Yeah, but really you should know, you're a confident mathematician, you should be able to do this. Because how do we start? Well, we're going to turn this mixed number into an improper fraction, or top heavy, and that is going to be the same as 9 over 5. So 1/4 over 5 is equivalent to 9 over 5, because I do 1 times 5, which is 5, plus 4, so 9 over 5. And please check all my other videos about fractions where I explain that in more detail, yeah? But now a little bit quick, 1 times 5, plus 4, so 9 over 5. Divided by 3 over 7, they say, yeah? So that's my first step and my first point. Now, dividing by fractions we don't really like, so what do? We will do 9 over 5 times, but then we take the reciprocal, which means basically the denominator becomes numerator and the numerator becomes denominator. You flip it if you want. If you want to call it flip the second fraction, you go and you call it flip the second fraction, all right? Because multiplying fractions, as we noticed already in the previous question, is quite straightforward. You multiply numerators and you multiply the denominators. So 9 times 7, 63 over 5 times 3, which is 15. There we go. Okay, 63 over 15, and I can see a common factor of 3. Well, you can plug this in your calculator anyway. I know they tell you without using a calculator, but please don't think they're going to arrest you if you now plug this in your calculator to simplify. But I see a factor of 3, which is common. So what is that? 5 and 21. Am I correct, guys? Please correct me if I'm not. 21 over 5, top heavy. Give it as a mixed number. Always looks a little bit better. 4 and 1 over 5. Good. That was that. Moving on to the next question. I'll see you there. So we're now at question 10 and 11. And if you just joined us, we are doing an entire past paper or past maths paper, and we're doing the paper 21 of May-June 2015. So please check my site explainingmaths.com, where you'll find all my other resources, and I explain all the topics for the IGCSE maths curriculum. All right, now let's have a look what's going on. Question 10. I imagine, or I think, some sort of distance or speed time graph, because they always look a little bit the same, don't they? Let's make it a little bit smaller. Okay, there we go. And indeed, it is a speed time graph. Now, before reading the question, I take a moment to really make sure that I understand the graph, because people make mistakes interpreting these graphs because they're thinking they're looking at a distance time graph. No, this is a speed time graph. So what do these lines mean? It means I'm accelerating, I'm going faster, and this means for a speed time graph a constant speed. And it's actually also the highest speed of my journey. It's the top speed of my journey. And this line means I'm decelerating, so I'm going slower, but I'm still going forward. Okay, that's important to realize. Well, if this would have been a distance time graph, then I would actually be standing still here, and this would have been a constant speed, and this would have been a constant speed. Yeah, but clearly it says speed time graph, so constant speed, top speed as well, accelerating, decelerating. Okay, now what are they saying? They're saying a tram leaves a station and accelerates for 2 minutes. So that's in bold, and whenever you see something in bold, put a line underneath it, because we still tend to miss it. It's important. They say it for a reason. And while you're reading it, you should also be shouting to yourself 2 minutes. Not out loud, of course. The examiner is not going to enjoy that, but mentally. So I'm reading the question mentally now. A tram leaves the station, accelerates for 2 minutes. It's important. I'm telling myself it's important, John, until it reaches a speed of 12 meters per second. So let's have a look. Accelerating for 2 minutes, and indeed a speed of 12 meters per second. Okay. It continues this speed for 1 minute. Yeah, that's right. It then decelerates for 3 minutes until it stops. So 1, 2, 3 minutes deceleration. Oh, that was an email, by the way. And then it stops at the next station. Okay, the diagram shows the speed time graph for this journey. So please take your time interpreting the graph. Read the question carefully, connect it back to your graph, what's going on, because now we have a very clear picture of what is going on, and that is going to help us to answer the question correctly. Calculate the distance in meters between the two stations, between station A, where he starts the journey, and station B, when he gets there. And you have learned to find the distance when you are given a speed time graph, and then you have to calculate the area underneath the graph. Now, there's several ways of doing that. some of you prefer to break it up. You can cut it with your scissors, your mental scissors, and then you find the area of the triangle, you can find the area of the rectangle, and the area of this triangle. You plus them together and you find the total area, which is the distance traveled. That's fantastic. You can also realize, well, this is a quadrilateral with one pair of parallel sides, so it's a trapezium. And what is the area of a trapezium? It's the sum of the two parallel sides divided by 2 times the height. Okay, but it's important, we didn't do anything with the 2 minutes yet, because the units are different. Yeah, the time is in minutes while the speed is in meters per second. So I'm either going to change this into seconds, and that into seconds, or this into meters per minute. And I'm going to do the last thing. So if it's 12 meters per second, then he is traveling at a speed of, what is that, 720 meters per minute. Okay, you got to be working with the same units, and there's a reason why that's in bold. Okay, so now the area of the trapezium, so I said the sum of the two parallel sides, so that is 1 plus 6, so the sum of the parallel sides, 1 plus 6 divided by 2, and then times the height, and the height is no longer 12, no, the height now is 720, 720 equals, and then your answer to that, if you plug it in your calculator, is 2,520. There you go. Moving on to the next question, sequences for 1 point. So it's to start with, so it's probably a linear sequence. Find the term-to-term rule. What is that? From 4 to 8 plus 4 plus 4. As you can see, it's a constant addition. So the term-to-term rule is plus 4. So I write down 4n straight away. If the term-to-term rule would be plus 6 plus 6 plus 6, I would write down 6n. But then I always check, is my first term 4? And if not, by what do I have to plus or minus it to get my first term? So is my first term 4? Yes, it is. So plus 0 and nothing. This is it. Minus 0. So my nth term rule is 4n. Always check it for a particular term. Let's say term 5. 4 times 5, 20. So 1, 2, 3, 4. Indeed, it's 20. Okay, so 4n is the nth term of this particular sequence. Moving on to the next one. 11, 20, 35, 56, 83. It goes up quite dramatically. And, well, as you will see, plus 9, plus 15, there's not some sort of constant addition. Now, there are several ways that you can do this. And because this is a quadratic sequence, it's also not... the terms are also not multiplied by a similar number every time. No, it's a quadratic sequence. Again, there are several ways of approaching this. A more algebraic way, I'm not going to do that one because students don't really like that one. This is what I'll do. I know it's a quadratic sequence. I'm going to write down the square numbers on top of my terms. Yeah, what's the first square number? It's a 1, and then 2 squared and 3 squared. And what is that? 4 squared and 5 squared. So I'm going to write down the square numbers, and then we're going to have a look at, okay, what is happening? Yeah, so if that is n, that's my sequence, and that is n squared. Yeah, so if my term number is 1, then n squared is 1. If my term number is 2, n squared is 4. If my term number is 5, n squared is 25. And we're going to look at, okay, what is happening with that square number to get the actual term number. And always start high. Do not look here because too many options. Start high, 25. How can I go from 25 to 83? Well, obviously I can add it with a large number. What is that? I can add, 58 to it, but it's not plus 58 because that's not going to work for all the other terms. Now, if I take my n squared, I'm just going to write it down here already, n squared, and if I now multiply that by a particular number, for instance, what is close to 83? 25 times, times 3. So if I multiply that by 3, so this is a little bit trial and error. So if I take the n squared, 25 times 3 is 75, and how do I get 83 from 75? So that will be plus 8. So I'm just trying it out a little bit. I'm looking at those square numbers and how can I get from 25 to 83. I always start with the largest one because that's the least amount of possibilities It's always a little bit clearer if you start with that one. Now this is it basically, but I'm going to check that for, let's say, the 16. So if I for term number 4 squared 16, 16 times 3, what is that? 30, 48. 48 plus 8 is indeed 56. So that's a very useful way to find the nth term of a quadratic sequence. You know it's quadratic because it's not a constant addition. There's also not a constant multiplication. So write down those square numbers at the top and just look at the larger term. How can I go from 25 in this case to 83? I could also do times 4, which is 100, and then minus 17. Yeah, so if I would do that, so 4n squared minus 17. But then if I would check that for another term, I will notice that doesn't work, okay? So it is n squared times 3, 75, plus 8, and that also works for, the other terms. So that must be it. All right, let's move on to the next question. So we're getting now to question 12 and 13, and usually these paper 2s are about 25 shorter questions. Yeah? So we are roughly at the middle now. Let's find out what's going on here. P is inversely proportional, so this is about variation, inversely proportional to the square of q plus 4. When p is 2, q is 2. Find the value of p when q is minus 2. Now, you will get a question like this, either inverse proportion or direct proportion, and there's a particular format, and you will always be able to correctly answer these types of questions. So again, check my site explainingmaths.com, where I explain that in more detail. Now a little bit quicker. Inverse proportion, I always start writing down y equals k divided by x. Okay, and now I'm going to substitute the letters they give here into this equation of inverse proportion. They don't say y, they say p is inversely, so I'm going to write down p is inversely proportional to this constant over the square of x plus 4. So x plus 4 squared, there we go. Then they give me two values, and I need those values to find that constant. They say p is 2 when q is 2. So I'm going to substitute that, because I want to find the constant 2 plus 4 squared. And then let me continue here. 2 equals k over 2 plus 4 is 6 squared, 36. So k equals, what is that, 72. All right, there we go, 36 times 2. So I found a constant. So again, always the same format, general equation, substituted with the values they give, use the 2 points they give to find k. K is 72. So in this particular case, and I'm going to continue here, it is p equals 72 over q plus 4 squared. And now I found the equation. I'm going to use that to answer the actual question. They say, what is p when q is minus 2? So what is p when q is minus 2 plus 4 squared? So what is that going to be? Minus 2 plus 4 is 2 squared. 4, 72 divided by 4. What is that? 18. There we go. So no surprises there, really. Just got to take some care of your work. Moving on. A car travels a distance of 1,280 meters at an average speed of 84 kilometers per hour. So again, those units are different. Calculate the time it takes for the car to travel this distance. Give your answer in seconds. Okay. Now, I'm going to make sure those units are the same. And how do I find the time? The time is, what is that? The distance divided by the speed. And if you ever forget that, just think of an easy example. Let's say I traveled 20 kilometers and I traveled at a speed of 10 kilometers per hour. Okay, how long does it take me? Well, yeah, 20 divided by 10. It's going to take me 2 hours. Everybody understands that. 20 divided by 10. So distance divided by speed is going to give me the time. Okay, so if you ever forget that, just make an easy example for yourself and you will remember. So distance divided by the speed. But we've got to make sure those units are the same. And I've got to give my answer in seconds. So there's several ways of doing it. Distance 1280 divided by, and I'm going to give the speed now in meters per second. Okay, so I'm going to work that out, meters per second. I'll do that in blue over here. So 64 kilometers in 1 hour. I always like to write it down as a fraction like this if I'm converting, because then I see that is 64,000 meters in 3,600 seconds. An hour, 3,600 seconds, because 60 minutes and 60 seconds in a minute, that's a number you just want to know. So it's 1,280 divided by 64,000 over 3,600, or perhaps you want to simplify this first. You don't have to, because you're going to get the answer 72 if you do this correctly. Okay, moving on to the next question. So the next question, a nice question about vectors. So we're still doing this entire past paper, 2015, I believe was paper 21, May, June. And I'm Mr. John from explainingmaths.com. So a question about vectors. What does it say? PQRS is a quadrilateral, PQRS, and M is the midpoint of PS. Okay, so I'm just going to put a little line here and a line there. That means that those lengths are equal. Okay. What do they say? PQ is A, and it's important, those arrows, because a vector has a particular magnitude, a particular size, and direction. So the direction is important. This is A from P to Q. So from Q to P, it would be minus A, the opposite direction. Okay, QR is B. It's there. And SQ, they say, is A minus 2B. So from S to Q, is A minus 2B. I'm going to write that down because they don't give me that without reason. So I'm going to write that in my diagram with that direction. That would be A minus 2B. So you see, they do not always give all the information in the diagram. So make sure you read it properly. And the direction again is important, from S to Q. Good. What are they asking? For 1 point, by the way. Show that PS, from P to S, is 2B. Now, I cannot go directly from P to S because I have no information there. So I'm going to take the tourist route. I'm going to walk the paths of the known. Okay, what do I know? Well, I can go from P to S, for instance, taking this route. Okay, A plus B, but I do not know RS. But I can also go from P to S, taking this route. You see that? Okay, and from these paths, I have all the information because PQ is A. So I'm going to write down A. And then from QS is the opposite direction of SQ. So opposite direction minus, and then please in brackets, A minus 2B. Because everything is in the opposite direction. So plus 2B. And that equals 2B. Now it's nice that they give you the answer. You have to show it. All right. So perhaps if you would have forgotten those brackets and you say A minus 2B, then your answer would have been minus 2B, a negative 2B. And that's not what they're saying. So, whenever your answer is different than what they tell you to show, then you got to check, what am I doing wrong? Yeah. I forgot the brackets. Put the brackets there. A minus A is 0 and minus 2B is 2B. Good. Moving on. Question B. For 2 points, write down a mathematical name for the quadrilateral PQRM. So what is that? PQRM. There we go. So not for the entire thing. No, just here. And give reason for your answer. Now, they say PS is 2B. And we didn't do anything with M with the midpoint yet. So again, remind yourself, they never give information I don't use. So if this entire thing is 2B, that means it's BB, if you like. So if I look at this quadrilateral, then this is B and that is B. So it's equal in length, plus they're also parallel. Okay, so what kind of a quadrilateral is that? That's going to be a parallelogram. I always have to think how you spell that. Logram. Like that. Why is that? Because PM, I'm not going to write it down. PM is equal in length to QR, and PM is parallel to QR. Now I have to say, it's a rubbish sketch. I know it's not to scale, but it's really a rubbish figure because it doesn't look like a parallelogram at all. It looks more like a trapezium. And actually, if I look now at the answer key, they say special case. If you, as a student, would have said trapezium, you would also have been given a point, yeah, because they realized they made a rubbish sketch. However, mathematically speaking, yeah, forget about the sketches, you should have been able to say, well, if this entire thing is 2b, so that is b, that is b, they're also parallel, so it's a parallelogram. Okay, next question. So this is the next page again, 15 and question 16. So we're getting towards the end now. And I'm explaining maths.com, and we're solving this past paper, entire paper together. So this is clearly something about graphing inequalities or linear programming, and I see some interest here. Okay, let's find out. I'll make it a little bit bigger so we can have a proper look. There we go. Let's find out what's going on. I see this diagram again. I see inequalities because I've been shading something, dotted lines. Write down the 3 inequalities which define the unshaded region. Okay. What do the dotted lines mean? It means it's not part of the solution, and just a normal line. So a continuous line means the line is also part of the solution. So let's start with the dotted line. This is the wanted region. Okay, that's also important to realize. It's a horizontal line, so if it would be just an equation, we would say it's the line y equals 8. The y coordinate is 8 everywhere. And again, I keep repeating myself, check my site explainingmaths.com, where I explain this in a lot of details. I have a lot of videos about lines, coordinate geometry. But this is a line y equals 8. So if we are only interested in that part below that line, then the inequality will be y smaller than 8 and not equal. Why? Because it is dotted. Okay, and this is what we're going to be doing for the other 2 lines as well. And we're going to first look at the equation, and then I'll turn it into an inequality. So y equals, now mx plus c in general, let me write it down here for you. Y equals mx plus c, where m is the gradient and c the y-intercept. So what is the gradient of this line? Well, if I go 1 unit to the right, I go 1 unit up. 1 unit to the right, 1 up. So the gradient is 1, so 1x. And what is the y-intercept? Where does it cut the y-x? At 2. There we go. So x plus 2. Now we're going to turn that into an inequality. Yeah, and we are interested in a part, the unshaded part is above my line here. So what is the inequality? Y has to be bigger or equal to x plus 2. Don't forget the or equal, because it's a normal continuous line. The last one is for 4 points. I love these questions, a lot of points. The line is going down, if you like, so I must have a negative gradient. Y equals, let me have a look. What is the gradient? Well, 1 unit, 1 down, 1 unit, 1 down. So it's going to be minus 1, so minus x. And what is the y-intercept? Well, it cuts the y-x at 6, so plus 6. And as an inequality, again, it needs the unshaded area is above this line as well. So it has to be bigger than the line y bigger or equal to minus x plus 6. Good. That was that. Let's move on. Oh, I don't do that like that. I should be doing it like this. For 4 points as well. Loads of points to be earned here. Something about compound interest. So please distinguish between compound and simple interest. George invests $5,000, lucky guy, for 14 years. That's a long time, by the way, at a rate of 2% per year. Compound interest. Calculate the interest he receives. Okay, I'm going to highlight that because I'm not interested in how much money he has, what is the interest he receives, and give your answer correct to the nearest dollar. Okay, that's all important. And please, you have a pen or a pencil when you do these exams, put those lines there yourself, because we tend to forget to round at the end, or we tend to forget to find the interest George receives. Okay, compound interest, how do you calculate that? Again, I explained that in more detail, but in my other videos. But you do the amount he puts in the bank, which is 5,000, and I'm going to times that by 1.02. And why 1.02? Well, it's 2% compound interest he gets. So the money after 1 year is going to be 102% of his original amount. So 1 is the 100%, 0.02, that's 2%. Not 1.2, because 1.2 would be 20%, okay? So 5,000, the money he puts in, 1.02, but he's not doing it for 1 year, he's doing it for 14 years. So to the power of 14, because actually, if you want to write it out, you could say, well, that is 5,000, and then after 1 year, he's going to get this amount, and then after 2 years, that, and then after 3 years of that, and 4, but that's going to take a while, so it's going to be to the power 14, the amount of years he gives it to the bank. And if you plug it in your calculator, you're going to get 6,597 point, what is it, 3,9, perhaps some other values. But that's not my final answer, because that's why I highlighted it to the nearest dollar, but also how much interest does he receive. So this is the amount of money he has after 14 years, but that's not his interest. No, because he started with 5,000, so I have to take the money he gets out of the bank after 14 years, take away the money he gave to the bank, and then correct it to the nearest dollar. I have $1,597 to the nearest dollar. Okay, so it's really important to highlight those important pieces of information. Next question. All right, here we are, question 17 and 18. And we're going to start with prime factorization. Write 30, it says, let me make it a little bit bigger, as a product of its prime factors. Now, you know what factors are, and I hope you know what primes are. Prime is a number with exactly 2 factors, like 2, 3, 5, 7. And I have to write 30 as a product of its prime factors. Now, what do they mean with that exactly? I am going to, first of all, divide it by the lowest prime, which is 2, because 30 is the same as 2 times 15. Okay, now 2 is a prime, but 15 is not a prime, so I'm going to divide that. Can I divide 15 by 2? No, so I move up. What is the next prime? Is 3, because 15 is 3 times 5. Now 5 is also a prime, so 30 as a product, multiplication of its prime factors, these are factors, will be 2 times 3 times 5. That's a product of the prime, these are all prime numbers, factors of 30. 2 times 3, 6 times 5 is 30. Then find the lowest common multiple of 30 and 45. Now, low doesn't mean that it has to be less than 30 or 45, all right? Low means, the lowest. Common, what they have in common, multiple, and multiples are your timetables. So what I suggest you do, just write down a few multiples of each number: 30, 60, 90, 120, 150. So I'm writing the multiples of 30, 2 times 30, 3, 4, 5 times 30, perhaps another one, 6 times 30. And I'm going to do the same for 45. 45, 90, 135. And then I see, oh, hang on a minute, they already have one in common. You see, 90. So that is their lowest common multiple, 90. There we go. All right, and then our classic, solve the simultaneous equations. You must show all your workings for 4 points. Now again, a guaranteed question almost, okay? So make sure you're prepared, make sure you have practiced this. Well, considering you are here with me, I think you can tick those boxes because you are practicing, that's good. Now, there are several methods, elimination, substitution, and I think most of you prefer elimination, so that's what we will be doing. And important with that is that the variables are correctly ordered on top of each other, which they are, so that's great. We don't have to do that. But in order to be able to eliminate one of the 2 variables, their coefficients need to be the same. But they're not. The x is 5, the x is 3 there, and 2 and minus 5 for the y. So I have to multiply one or both equations to make them the same. So let's eliminate x. By what can I multiply the equations? Well, I have to multiply this one by 3 and that one by 5 in order to get the same coefficient there for my x. So I have to multiply both. Well, that's not necessarily a problem. So, I need the pen though. 15x plus 6y equals minus 6. So I have to multiply all the terms by 3. And again, I explain this in more detail on my site, explainingmaths.com, but just to show you that this is not some trick, let's say 5 plus 3 equals 8, right? Agree? And if I would multiply everything by 2, for instance, I'm just making up the numbers now, then it would say 10, 5 times 2 plus 6 equals 8 times 2, 16. So as long as I multiply all the terms by 2 or by a particular number, the equation is still true. I'm going to do a similar thing here. This is exactly the same as this, but make sure you multiply all the terms by 3, and we tend to forget this one. Okay, same for the other one, times everything by 5. So, come on. Oh dear, what did I do? I lost my black. Okay, do I have it back now? 15, yeah. Sorry, perhaps some of you prefer the green, but I prefer the black. 15x minus 25y equals, well, it's a little bit late now. It's almost 11 o'clock in the evening. I've had a long day of work. I'm going to use my calculator now. 17.4 times 5 equals 87. Fantastic. All right, I'm going to put some brackets there because I want to look at those equations simultaneously at the same time. The coefficients of my x are equal now, so I can eliminate them, but always take a few seconds to really clearly define whether I have to plus or subtract in order to eliminate. So 15x minus 15x would be 0, so I have to minus. And in class, I tell my kids, look guys, I have one finger which is purely for math. So I use my finger on the board and I point to 15x minus 15x 0. And why do I use my finger? And I still use my finger, guys, even now I'm 35 years old, because especially here people go wrong if they don't use a finger. 6y minus 25y. So if you take your time, if you're calm, if you're confident, if you use your finger, you will not make the mistake, because 6y minus 25y is 31y. It's plus minus minus, okay? If you go too quickly, oh, 6y minus 25y, perhaps some of you are going to say, oh, it's minus 19y. Yeah, but that is wrong, yeah? So keep calm, relax, and do your working properly. And use your finger. Minus 6 minus 87. That's going to be minus 93. There you go. Then y is minus 93. I eliminated x. I'm going to find y now. And that is minus 3. Fantastic. Let's put it here. Minus 3. I'm not done yet. Yeah, because I also want to find x. How can I find x? I'm going to substitute my y value in one of the two equations. Doesn't matter which one. Let's take the second one. So 3x minus 5 times minus 3, yes, equals 17.4. So 3x plus 15 equals 17.4. 3x equals 17.4 minus 15, so that is 2.4. So x equals 2.4 divided by 3, 0.8. I'm just going to write it there now, 0.8. Fantastic. Moving on, question 19. So question 19, two triangles, not to scale, but they look quite similar, so probably similarity. Let's find out. Triangle ABC is similar indeed to DEF. All right, calculate the value of x and then y, both for 2 points. Again, several ways of approaching a question like this. You can find a scale factor or whatever you want to do. How do I approach it? I always write down, I start with my unknown, what I want to find out, x. Oh, I need a pen though. X over, and I'm going to look at the corresponding length in the other triangle, and that's obviously BC. That's what you would say, but I still want to check that. So triangle ABC is similar to DEF. So because that is important, that means that AB is similar to DE, BC corresponds to EF. So that's important, but I already expected that. So it's x over 10, and that has to equal, I'm not going to find two corresponding sides that I both know the length of, right? And I know 8 and 6. So I started in the smaller triangle x, so I got to start in the smaller triangle again, so 6 over 8. And now I'm going to work it out, but I also tell myself before I start, x is going to be at least smaller than 10. Because if I get an answer bigger than 10, then I just have to turn these around. I made a bit of a silly mistake there. 6 over 8 times 10, your answer should be 7.5. There you go. Same for y. This is y, and it corresponds with df, and df is 9, so y needs to be bigger than 9. That's what I'm telling myself. So y divided by the corresponding side equals, now I started in a larger triangle, so I'm going to start in a large triangle again, 2 corresponding sides that I both know the length of. So 8 divided by 6 times it by 9, you're going to get 12. And that makes sense because it has to be bigger than 9. Factorizing then, moving on to question 20. Let's make it a little bit bigger. The first one, now if you factorize, the first question you have to ask yourself is there a common factor? And if you look at all 4 terms, there is not a common factor. And then the second question you ask yourself, can I factorize by grouping? And grouping is a very specific way of factoring, and you need 4 terms for it. And as you can see, you have 4 terms. And if you have some experience and you've studied the material, you see very quickly, you identify this is grouping. So what do? I look at the first 2 terms and I take out the common factor, which is y, and then in the brackets p plus t. So check my site explainingmaths.com where I explain this in a lot of detail. I'm going to look at the next 2 terms, and again I have to take out the common factor, and then I keep my fingers crossed because inside the brackets I should get the same as here, p plus 2. Let's find out what is the common factor. 2, and they both have an x, so the common factor is a positive 2x. What is left in the brackets then? P plus t, and that indeed is the same. That's what I expected, but it's always nice to see that I was actually right. So what is my final answer? Well, it's p plus t times 1 times y and 1 times 2x. There you go. Well, you could also turn this around, doesn't matter. Yeah. And then question B, and now this is a little bit of an unusual one. I haven't seen this one many times, so it's interesting. Again, factoring, the first question you ask yourself, is there a common factor? And yes, there is. Let me just write this differently, because 7 times h plus k squared means 7 times h plus k times h plus k. Yeah, that's what the squared means, minus 21h plus k. Now, what is the the common factor? The 7 and the minus 21, they both have a factor 7. So I'm going to take the 7 out, but I have more, another common factor. They both have a bracket with h plus k. So I can take that one out too. Bracket h plus k. And then in the big bracket, what is left if I take out 7h plus k? Well, of this first term, the 7 is out, so that is a 1. And I take one set of brackets h plus k out. So inside the bracket then goes h plus k. That is what is left. That's this one. Minus 21. If I take the 7 out, I'll be left with a minus 3. And the h plus k is out. So this is your final answer. Okay? So it is a very typical factoring question, I have to say. But it's you can factorize it by taking out the highest common factor, because they indeed say factorize completely. So you have to take out the highest common factor. Next question. So mensuration, clearly, some three-dimensional object for 4 points. So it's quite a large question. Let me make it a little bit bigger. It says the diagram is or shows a toy. A little bit smaller now. All right, there we go. The shape of the toy is a cone, as we can see, with a radius of 4 centimeters, all right, and a height of 9, on top of a hemisphere. Okay, so half a sphere, half a football, half an orange, also with a radius of 4 centimeters. Calculate the volume of the toy. Yeah, so what is the capacity of the toy? Give your answer correct to the nearest cubic centimeter. Oh, many people are trying to reach me, but they'll just have to wait. So to the nearest cubic centimeter, so I have to round at the end, don't forget that. And we don't have to memorize those formulae anymore, so they give them to me. The volume of a cone and the volume of a sphere. Now let's start with the cone. Yeah, I'm going to find the volume of the cone. Then I'm going to find the volume of the sphere, and then I plus them together. So the volume of the cone, let's start here. Volume of the cone is, what is it? 1/3 times pi times the radius. What is the radius? 4 squared times the height, 9. And yeah, you can plug that in your calculator. Let me just keep that in terms of pi. So what is that? 16. Yeah, times 3, so 48 pi. I'm going to leave it in terms of pi. I mean, you can already work it out, but I just don't want to be writing down all those decimals now. The volume of the hemisphere, HS, hemisphere, is 4/3 times pi times the radius, which is 4 cubed. But that's of a sphere, so all of that I have to divide that by 2. Okay, and that will equal, put it in your calculator, in terms of pi, 128 pi over 3. There we go. Over 3? Yeah, over 3. So plug it in your calculator properly. So what is the total volume? Then I have to plus those together, and which is going to be 128 plus 48. So I want to do that correctly. You know what? I'm gonna not do it in terms of pi anymore. It's gonna give me 284.8 and some more decimals, and that is centimeter cubed then. However, they ask me give your answer correct to the nearest cubic centimeter. So that's why I highlight that at the beginning, because otherwise I forget. It's a long question, so please highlight it. So 284 point, and then the first decimal is higher than a 5. So to the nearest cubic centimeter, 285 centimeter cube. All right, so don't forget to divide that by 2 for the hemisphere. And for the rest, it's a fairly straightforward question because it's all about substitution. They give you the formula. All you got to do is substitute the radius into it. Yeah, do the same for the hemisphere. Divide it by 2. You plus them and you round it. Okay, let's find out what the next question is all about. And the next question is about matrices, and some of you love them, some of you hate them, but all of you need to be able to answer these questions, okay? And check my website, explainingmaths.com, where I explain this in detail. This is the first question, is about multiplying matrices. And I always prefer to rewrite the questions slightly for myself, but you do whatever you prefer. But I prefer to write it like this, because especially the multiplying the matrices can be slightly confusing. So I'm going to write the first matrix just normally, and then the second one here at the top. There we go. And then we have, I'm going to write my answer. I'll do it in blue over here, because that kind of reminds me that I have to work horizontally here and vertically there. Because how do I find the values? Let me just put some dots there as well. First of all, sorry, I'm skipping a few things, guys. Again, check my website for more information. But this is a 2 by 2 matrix. That order is also 2 by 2. So the inner numbers show me, yes, I can multiply it, and the outer numbers will tell me the order of my answer, which then is a 2 by 2 matrix. Yeah? So I hope you realize that. So that's why I can put those 4 dots there. And then this dot, this piece of information, is 3 times minus 2. So I'll write that here, 3 times minus 2 plus 3 minus 2 plus 7 times 4. So plus 7 times 4. So minus 6 plus 28. So that's going to be 22. Okay, now I'm going to work it out. I'm not going to work it out for all of the pieces of information, but now for this one, it will be 3 times 1 plus 7 times 2. And if you do that correctly, it is 17. Moving down, so we're moving down here too. For this one, it's minus 1 times minus 2 plus 4 times 4. And if you do that correctly, you're going to get 18. And the last one, minus 1 times 1 plus 4 times 2. And that will be, or that is 7. There you go. So that is the answer. Yeah, you have to write it here. So 22, 17, 18, and 7. Okay. The next question, calculate the inverse. And we only have to do inverse matrices of order 2 by 2. And what do you do? What did I explain in all my videos, which you can find on my website, is that you have to swap A and D, and you change the signs of B and C. That's how you start. So I'm going to swap A and D, so the 4 goes here and the 5 goes there, and the positive 3 becomes -3 and the positive 6 becomes -6. Okay, so that's the first thing. However, there needs to be something in front. 1 over the determinant. Right, and what is the determinant again? That is, now you have to look at the original matrix, and not like this one. You have to look at the original one. What is the determinant? It is AD minus BC. So 5 times 4, which is 20, minus 6 times 3, 18. So my final answer will be a half. Yeah, 1 over 2, and then 4, 5. They swapped position, and they just get the opposite sign. There we go. So that's fairly, I think it's simple. I mean, you practice this 10, 20 times and you know it. That's why we only get 2 points for it. Let's go to the next question. We're almost there. So it's the final question. So this paper, 23 questions. This was the paper 21 out of 2015, May, June. And the last question is about functions. They give a function fx, 5 minus 3x, and they ask find f6. So evaluate the function for 6. So 5 minus 3 times 6, so 5 minus 18 minus 13. And I'm going to ask almost the same question, but now we're going to evaluate it for x plus 2. So I have to substitute x plus 2 for x. Excuse me, so it's going to say 5 minus 3 times x plus 2, which is 5 minus, 3x minus 6. So it's minus 3x. An email, there we go, minus 1. Good. Find f of x in its simplest form. And that is a composite function, where I have to put the function f in f for x. So what does that mean? That means 5 minus 3 and 4x, I'm going to put in the function f, which is 5 minus 3x. There we go. And then we're going to expand that. 5 minus 15 plus 9x, and 5 minus 15 is minus 10 plus 9x, or if you like, 9x minus 10. Fantastic. Find the inverse function of f, and always write down y equals, rather than fx, 5 minus 3x. Then to find the inverse, we have to swap x and y. There are other ways of doing this as well, by the way. Perhaps you prefer a flow diagram, but this makes the most sense to most students, I think. So you swap x and y, and then we got to make y the subject again. So let's start with the equal sign. That's 3y, 5 minus x. Divide the entire thing by 3. So 5 minus x, and all of that divided by 3. Good. Now we are finished, ladies and gentlemen. The entire paper we have solved now together. I hope it was useful. Please like and share if it was. And check my website explainingmaths.com, where you will find me explaining all the topics you need to know for your IGCSE or GCSE maths exam. I wish you a very pleasant evening, and I'll see you later. Bye-bye.